In this question, a team of 4 students is to be selected from a total of 12 students. We need to figure out the total number of ways in which a team can be selected such that 2 particular students refuse to be together and 2 particular students wish to be together. Yes. So let's begin. Let's understand the situation. So there are 12 students and I need 4 students in my team. Okay. And out of these 12, 2 students wants to be together and 2 students don't want to be together. So let us assume S1 and S2 are the students who wish to be together and S3 and S4 are those students who don't want to be together, who refuse to be together. So how many cases are possible? That is the one thing, the core of the question is how many cases are there. So we need to think all the cases. If one case we miss out, the answer will be wrong. Please keep that in mind. So first case is, let's exclude everyone. So S1 and S2 we are not including. So they are not in my team. That is cool. If they are in my team, then both of them should be there. If they are not, then it's totally cool. So S1 and S2 excluded and S3 and S4 both are also excluded because they are saying that if one will come, another will not come. Right? So I have excluded everyone, S1 and S3. So exclusion, excluded everyone. Now in second case, let's include S1 and S2 because they want to be together. And S3 and S4 excluded. So include this time S1 and S2 and S3 and S4 excluded. Can there be third case? In third case, what we can do is S1 and S2 excluded. S1 and S2 excluded, but 1 out of S3, S4 we can take. Right? 1 out of S because both will not come together. S3 and S4 refuse to be together. That means 1 of S3 and S4 included. This is the case. And fourth case, S1 and S2 both are included this time, and the same case with S3 and S4, 1 of S3 and S4 we have included. These are the only 4 cases. Think about the another 5th case. You will find out that there is no case which we have missed out. Right? Let's begin now. Case number 1. So let me delete all these cases and let's discuss cases one by one. Case number 1, when all are excluded. Yes, all 4 are excluded. So there are particular persons. Particular. So 12 are there. 12 minus 4, I am not interested in these 4. So 8 will be left. And out of 8, I can select anyone, no condition. So that will be done by 8C4. If you solve this, you will get 70 as the answer. Case 2. In case 2, S1 and S2 are included. These two wants to be together. I have included these. But S3 and S4 I have excluded just like this. Now, from 12, 2 are already selected, 2 particular. That means I need 2 more person. Right? So, out of 12, if I subtract these 4, I'll get 8. Right? 2 are already in my team. So, I need only 2 more out of these 8. So, that will be done by 8C2 ways. That is equals to 28. Okay. This is the case 2. Let's talk about the case 3. Case 3 says we'll include S1 and S2, but we'll include 1 out of S3 and S4 because both of them cannot come together. One of them will come individually, right? So S1 and S2, so there are 12. Let's subtract these 4. Let's subtract these 2 because these 2 particular are there. So 10 people are there. Out of these 10, 2 are these 2. Right? 2 are these 2. And so 10 minus 2 will be what? 8. Right? So actually what I have right now is S1 and S2 are in my team. 1 out of these S3 and S4, particular S3 and S4 I want. So that's the thing that we need to select 1 out of S3 and S4. That can be done by 2C1. Right? How many persons do I have in my team? S1, S2 and 1 more out of these 2. So 3 persons are there. I need 1 more out of these 8. I don't want S3 and S4 both together. Only 8 persons are left. I need 1 more. That can be done by 8C1. So that will be what? 8 2s are 16. So finally, you'll be getting 16 as the answer. Last case, when S1 and S2 are excluded this time and 1 out of S3 and S4 are included. So S1 and S2 are excluded. So 12 people are there. 12 students are there. And 4 are, let's subtract these 4, 8 are there. 2 are S1 and S2. 2 are S3 and S4, right? S1 and S2 I don't want out of the picture. Let's send them. 1 out of S3 and S4 I want. That comes selection out of these two. So again 2C1 will be there, right? Now how many persons do I have right now in my team? Only one. S2 and S1 are excluded already. So only one I have right now. I need 3 more out of these 8. I need 3 more, so that can be done by 8C 3 ways. So finally 2C1 multiply 8C3 will be equal to 112. So there are 4 cases. Either of these case is true. That means or means plus. If you add all the numbers, you'll get 226. So final answer of this particular question is option C, 226. Got it? In this question, it is given that 10 persons numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 play a chess tournament, and each player playing against every other exactly one game. Yes, there is a lot of information in this question. So this question demands patience and time. Okay, so there are 10 players, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and each player is playing against every other person. It is known that no game ends is a draw. That means no game is draw. Either someone wins or someone loses. That is the case. Let W1, W2 up to all the way up to W10 are the number of games won by the player 1, 2, 3, 4, 5, 6, 7, 8, 9. That means W1 are the number of games won by player number 1. W2 are the number of games won by player number 2, number and so on respectively. Similarly, L1, L2 up to L10 are the number of games lost by the players 1, 2, 3 up to 10. Right? So that means each player, suppose player 1 is playing some games, right? So either this player has lost some game or win some game. So W1 are the number of games this player has won, and L1 number of games this player has lost the games, right? So this is the information. Now let's move on to the option part, and the option looks bit scary. Sigma, W and all. But trust me, this question is trying to scare you. This question is not at all difficult. Just be patient and solve it and try to understand the options one by one. You'll find this question pretty easy. It's just the reading part and the solving part should be strong. Okay. So this is what sigma Wi and sigma Li. Index is 1 to 10. Okay. So what is this actually? This is W1 plus W2 plus W3 plus W4 plus W5 and all the way up to W10 plus L1 and all the way up to L10 is 90. We need to check this number. Okay. So that simply means that number of wins by player number 1 plus number of wins by player number 2 plus number of wins by player number 3 and all the way up to number of wins by player number 10 plus number of games lost by player number 1 and all the way up to number of games lost by player number 10. Sum of all is whether it is 90 or not, that we need to confirm. Okay. What is this? Wi plus Li is equals to 9. Wi, it is not there is no sigma involved. Here Wi plus Li means either W1 plus L1 we need to find. That means player 1 has win plus lose is 9. Player 2, W2 plus W2 plus L2 will also be 9. That means any player, number of win plus lost would be equals to 9. That we need to check. Okay. And this is another part which we need to figure out, part C and part D. Sigma Wi square in terms of sigma sigma Li square, right? So let's focus on part A and part B first. Part A and part B first. In that, we need to actually understand the whole situation, that how many games one player is playing, how many games are happening overall. So we need to actually calculate everything for this particular. Then only we can come to the option part. So 10 persons play a chess tournament that is given in the question, and each player played against each other exactly one game. For example, in a group we are 10 people. So I am playing with one person exactly one time. I'll not encounter the game with the same person twice. So I'll play one game with you, that's it. Then another game with this person, that's it. That is the agenda of this particular statement. Okay, so for example, 10 people are there, out of which one is me, and nine other people are there, right? One is me out of 10, and 9 more people are there. So how many games do I need to play? So with each and every 9 person, I'll play a game. That means I'll play total 9 games. Similar is the case with everyone, isn't it? That person will overall play 9 games because one is him itself, right? One is him itself, and he will play with other 9. So one by one, 9. So every player actually, and condition is no game ends as a draw. Nothing is draw, either win or lose. So it is clear that each player plays 9 games. That is no hard thing to guess that every person is playing total 9 games, right? Okay. And but overall, how many games are happening? Overall, how many games are happening? If another person is watching, then these 10% total, how many games they are playing, that we need to discuss. So total 10 persons are there, and with every 2 unique selection, I'll have a game. Are you getting my point? If I'm able to select two new combination of the person, then that will be a game. Out of 10 people, I need to select 2 unique persons. So 10C2, this can be done by 10C2, isn't it? So in 10C2, so total 10C2 games are being played. So that means 10 into 9 by 2, that will be 45. Total 45 games are being played, right? Okay, these two things are sorted. Now, each player is playing 9 games. Okay, suppose I am player number 1, I am playing 9 games, right? So overall 9 games. In some games I am winning the game. In some games I am losing the game. Okay, player number 1 is winning. The number of wins is denoted by W1 given in the question. Suppose I am playing 9 games, so 4 I am winning, 5 I am losing. Okay, so W1 is the number of wins, and L1 by player number 1, only player number 1 I am talking about. So L1 is the games lost by player number 1. So total win plus total lost will be equal to what? The number of games played by me or any other person. So W1 plus L1 would be 9. Isn't it? Win plus lose is the overall number of games I have played. W2 plus L2 would also be 9. W3 plus L3 would also be 9, and all the way up to 10. So Wi plus Li is 9. One of the options is sorted. Wi plus Li is 9. Where I is 1, at one time I is 1. So W1 plus L1, 9. W2 plus L2, 9. W3 plus L, W7 plus L7, 9. Everything is 9. Okay. And the total number of games we have already discussed is 10C2, 45, which we have already written over here. Okay, so total number of games which are happening is 45. Okay, so 45 games are happening. Do you agree? So if one game is happening right now, 2 people are playing, the match is not draw at all. So one person will win the match, and another person will lose the match, right? So each game is associated with one win and one lose. Do you agree? Each match, each game, each play is associated with one win and one lose, right? So 45 games are there. So 45 games are associated with one. That means 45 win and 45 lose. So total 90 win, 90 lose are happening over here. Are you getting my point? Because each match is associated with one win and one lose. So that means total number of win all the way W1 plus W2 plus W3 plus W4 plus W5 all the way up to W10. Summation Wi from 1 to 10 is 45. Summation Li from 1 to 10 is 45, just like this. Because every game is associated with one win and one lose. So 45 games are associated with one win and one lose. Another part is sorted of this particular question. Okay, so there are 2 things which are sorted this time. Sigma Wi, sigma win plus sigma lose is equals to 45, and Wi plus Li is equals to 9. One more thing we need to discuss, option C and option D, in which sigma Wi square we need to figure out in terms of sigma Li square. For that, I'll shift Li on the right hand side and square both the sides. So Wi is equals to what? 9 minus Li, right? Now I'll square both the sides. So left hand side will have Wi square. Right hand side will have what? 81 plus Li square minus 18 Li, just like this. Squaring both the sides just like this. Now I want sigma Wi square. For that, I need to apply sigma in each and every term. So sigma Wi square index 1 to 10, right, equals to 81 sigma 1 index 1 to 10. 81 is out of the sigma, or sigma 81 also we can do it, plus sigma Li square I equals to 1 to 10 minus 18 sigma I equals to 1 to 10 Li. 18 outside the sigma. Applying sigma everywhere in each and every term. So sigma 1 from 1 to 10 is 10. So this can be replaced by 10. Sigma Li square. Sigma Li square, let it remain as it is because we want Wi square in terms of Li square. Sigma Wi square in terms of Li square. And this is sigma Li, which is 45. So this can be replaced by 45. So our expression will be like this. Yes, 81 multiply 10, this. Sigma Li square, this. And 18 multiply this would be what? 45, right? This would be what? 45. So our expression will look like this. Now 81 multiply 10 and 18 multiply 45 are one and same thing. 810. So these two are cancelled out and I am left with actually sigma Wi square is equals to sigma Li square. This is the last option which we need to tick, where index is I equals to 1 to 10. So now option A is correct. Option A is correct. How? Because this one is 45. All the win is 45. All the lose is also 45. So overall 90. Number of win plus number of lose is equals to 90. And option B, Wi plus Li is equals to 9. For each and every player, the number of games he plays is 9. And number of games he win plus lose is 9. So this is also correct. And option D is correct. Option C is incorrect because this is wrong. The sigma Wi square is not equals to 81 plus sigma Li square, but is sigma Wi square is equals to sigma Li square. So option D is right. Okay. In this question, we need to figure out number of 4-digit numbers formed by 0, 1, 2, 3, 4, 5, where repetition of digits is allowed such that it is divisible by 6. Okay. So the number should be divisible by 6. A number is divisible by 6 if and only if that particular number is divisible by both 2 and 3 individually. Yes. So a number is divisible by 3 if it is a number is divisible by 6 if it is divisible by 2 and 3 both. Okay. And how many digits number you need to make? 4-digit number. Okay. So divisible by 2 divisibility by 2 is very easy. We need to make the last digit even. So either 0 or 2 or 4 will sit on the last place. Okay. Okay. And repetition is allowed. So how many digits do I have right now? Total 5 digits I have plus 1 0. Total 6 digits. 5 digits plus 1 0. 0 I cannot place on the first place because I want 4-digit number. So I have how many options for first place? 5 options I have. Right? 5 options. And similarly, how many options do I have for second place? In second place, I can put any number. Repetition is allowed. So 6 digits I have. So 6 I can fill second place by 6 ways. Okay. So second place has 6 choices. Similarly, third place also has 6 choices. But what about the last place? Now the number should be divisible by 3 as well. That we need to figure out. Right? Number is divisible by 3 if the number is of the form 3k. Right? If the number is of the form 3k. Okay. And the divisibility test of 3 says that the sum of all digits, let me mark the digits. Let's say the first digit is x1, then x2, then x3, and the last digit is x4. So x1 plus x2 plus x3 plus this last digit, which we are about to figure out what would be this last digit, should be divisible by 3. x1 plus x2 plus x3 plus some x4 should be divisible by 3. That means it is equals to 3k. First 3 digits are already decided, right? So first 3 digit can be of the form 3k. That is this digit would be multiple of 3, right? This digit, the sum of these 3 digits would be multiple of what? 3k plus 1, or it could be 3k plus 2. Are you getting my point? Sum of these 3 digits can be exactly of 3 forms, either 3k, 3k plus 1 or 3k plus 2. That means if you divide sum of these 3 numbers by 3, either remainder will be 0, or remainder will be 1, or remainder will be 2. Remainder cannot be 3 because again you can divide it by 3 and you'll get remainder 0. Okay? Okay, so these 3 numbers are there. Now, depending upon what is x1 plus x2 plus x3, we need to fix x4, isn't it? So if x1 plus x2 plus x3 is already a multiple of 3, then we need to place a number on this place x4 such that it is already multiple of 3. We cannot place a number of the form 3k plus 1 or 3k plus 2. Right? And in 0, 2, 4, which one is the multiple of 3? Absolutely 0. Right? So for this particular case, I have only one choice. Only one choice, that this x4 can be filled with only one way. Yes. Similarly, second case says, if x1 plus x2 plus x3 is of the form 3k plus 1, that means we are in need of 2. Right? We are in need of 2. So that means we need that number in place of x4 such that if we divide that number by 3, we get 2 as remainder. And that is exactly one number out of 0, 2 and 4. Which one is the number in which we will divide it by 3? If then we'll have 2 as remainder. So that is 2. Again, I'm having how many ways? One way. So if the number is of the form 3k, x1 plus x2 plus x3, then x4 has one way. Similarly, this also has one way. And third case, if the number x1 plus x2 plus x3 is of the form 3k plus 2, that means I am in short of 1. Right? So I need to put a number in place of x4 such that if I divide that number, I'll get 1 as the remainder. And that is number 4 only. Isn't it? We have to choose between 0, 2 and 4. So if I add 4 in this, what do I get? Tell me, 3k plus 6, which is divisible by 3. Right? Only choice I have in third case is 4. And only choice I have in second case is 3k plus 1 plus 2. So 3k plus 3 is divisible by 3. And similarly, the first case has choice 0. 3k plus 0 is divisible by 6. So how many ways? 1, 1, 1, 1 each. That means this will be filled by one way only. So finally, the answer would be 5 multiply 6. Multiply 6 multiply 1 is equals to what? Okay, 180. So finally, we'll have what answer? Final answer 180. Let us write it properly and understand one more time what is this concept trying to say. So let's delete what I have written over here, so that you have understood that we have 3 cases, right? 3 cases when x1 plus x2 plus x3 is multiple of 3. Then what will happen? Then I need one more x4 such that the overall sum is divisible by 3, right? So I have to add either 0 or 2 or 4. If you add 0, the number would be divisible by 3, 3k. If you add 2, the number would be of the form 3k plus 2, rejected. If you add 4, the number would be of the form 3k plus 4, again not divisible by 3. That means only choice you have, x4 can only be equals to 0. Possibility of x4 can only be 0. That means you have one way for this, case 1. Okay, what about case 2? Similarly, if x1 plus x2 plus x3 is of the form 3k plus 1, then only possibility is out of 0, 2 and 4, you only have to select 2. If you select 0, rejected. If you select 4, rejected. That number would not be divisible by 3. Okay, so that means you have one way for this as well. And similarly, if 3k plus 2, you need to add 4. You need to select 4. Again, one way. So finally, you have answer 5 multiply 6 multiply 6 multiply 1, which is equals to 180. So 180 is your answer. Got it?